Hey everyone, welcome back. In the last video, we learned about short polling, where the client repeatedly asks the server if there is any data. But as you might remember, short polling has one big problem. It wastes a lot of requests when there is no new data, right? So today we will be looking at a better alternative to short polling, and that is long polling. So we will be taking a look at the core idea. We will perform a hands-on demo so that you can understand how long polling works. We will understand the pros and cons of long polling, and finally, we will look at scenarios where it might be appropriate to use long polling. Before we jump into long polling, let us do a quick recap. We looked at the HTTP client server model, where the client will send the HTTP request and the server would respond back with a HTTP response. We also looked at a few properties of the HTTP protocol. One is that it is stateless, and the second one, it is client initiated. And these two properties of the HTTP protocol provide us a challenge in getting real-time data from the server. So the challenge is, how do we get new data immediately when the server cannot initiate contact, right? The server cannot reach out to the client has to reach out to the server, and in such a scenario, how do we get real-time data? So as a solution to that problem, we looked at an approach called short polling. In short polling, a client makes repeated requests to the server. Each of these requests will have a fixed interval between them, and they will fetch the data from the server. This approach had quite a few problems. The first one is, there is a fixed interval between each of these requests. So if you consider the data to be changing at any point, the client can get the data only in the next iteration when the client requests for it, right? So there is a considerable latency because of these fixed intervals, and that was one of the major problem. The other problem is that if the data on the server did not change very frequently, the client ends up making a lot of requests, and many of these requests will just return the same data or an empty response. And in such a scenario, we have so many wasted requests which simply add stress on the server, which is not a good thing. So now we look at a smarter alternative to that. And in this smarter alternative, which is known as long polling, the server holds the connection open until new data is available or until a timeout occurs, and then it responds immediately. This approach tends to reduce the total number of requests that the client needs to make, right? And will help reduce the load on the server. So the process could be divided into four simple steps. The first one is, a client will send the request, which is pretty simple. The second step is the most important step. The server will wait until data is available or a timeout occurs, whichever happens first, and then it will respond immediately. And once the client will receive that response back, it will immediately launch another request, right? So you make a request to the server will respond back with either new data or an empty or the same data because timeout has occurred, and then the client will repeat the same process again. The key point to note here is that we have a wait duration which is configurable, and the server will wait for a certain time before responding back. During the wait duration, if the data gets updated, the server will respond back with the updated data, or it will wait for the entire duration to be elapsed and then it will respond back with either an empty response or the old data, right? So for example, if you configure the server such that it returns the new data or it waits for 10 seconds before returning, then the wait duration would be 10 seconds, and if the data gets updated during the 8th second, it will respond back immediately and the client will receive the updated data. So that is the basic idea. Instead of responding immediately, the server will wait for some time to get the updated data, and if the data doesn't get updated within the timeout, it will close the connection. Now let us implement this smarter approach and see how long polling can reduce the total number of server calls and reduce the server load. In this demo, we will be utilizing Express.js and spin up a Express server that will expose an endpoint, and we will perform long polling on this endpoint. Do not worry if you have never worked with Express.js. It is really simple, and I'm sure you will understand this with the explanation. So all we are doing is we are exposing this endpoint, right? And we have two different variables that we have configured. The first thing is the delay, right? So we are trying to simulate a delay that would happen in a real server. If you make a HTTP request to a real server, that might fetch the data from the database. It might perform some validation checks on the data. It might perform some qualification logic on the data to determine what data is qualified to be returned to the client, right? And that might take some time. So in a real world scenario, the time would be much less, but to demonstrate here, we are simulating the time to be anywhere between 1 and 10 seconds, right? And we also have a timeout which is configured to 6000 seconds. We will use the timeout below. So these two promises are the main thing to understand. So the first thing is this new data promise. Once the timeout ends after delay seconds, delay is the delay that we defined over here, this promise will resolve to this object, which simply has a message that will read new data at and the time. We have another similar promise that would resolve to this message that says no new data at whatever time it was resolved at, right? And finally, we compute the result based on these two promises, and we use promise.race. So promise.race will take an array of promises, new data and timeout in our case, and it will take the promise that resolves first. So whatever happens first, either we get the new data or there is a timeout that has happened, right? And we simply return that result. That's it. It is very simple. There is an API endpoint that will either return a new data or it will return a timeout and say there is no new data, right? So this captures the logic of long polling very closely. Either we have new data that happens before the timeout or we have a timeout object, right? So assume that the data takes anywhere between 1 and 10 seconds to update on the server, but we also have a timeout of 6 seconds. So if the data updates within 3 seconds, we will return the new data because that is less than the timeout. But imagine the data updating at somewhere around 8 seconds, right? So 8 seconds is more than the timeout that we have configured, which is 6. So in that case, we will simply say there is no new data and we will return this particular JSON object, right? That is exactly what we learned in the core idea of long polling. So this was everything about how our server is configured. We have a second file where we simply make API calls to this particular API that we have just defined, right? And if the API call is successful, we get any message, either it is new data or a message that says we have no new data. In either of these successful cases, we will make the API call again, right? So in long polling, once the server responds back, you immediately make another request, correct? But if there is an error, we log the error and we wait for some time before we make the API call. In this case, we are waiting for 3 seconds. This is very close to what we do in a real scenario, because if an API is returning an error, we usually wait for some time before we make another API call, because if you make an API call immediately once it has returned error, chances are the second time as well it will return an error, right? So we wait for some time before we make the API call again. Let us execute both of these files now. The first file will set up the server for us, and the second file will initiate long polling on the endpoint that we just configured. So the server is now running successfully on localhost port 4000. Let's now initiate long polling. So we can see that we got the initial data at the 43rd second, and then we waited exactly for 6 seconds, right? 43 to 49. So we waited for 6 seconds, and that is the timeout that we configured. So 6 seconds elapsed and we didn't get new data, so we returned back with no new data. So again we waited for another 6 seconds from 49 to 55, and we said that okay, so we have timeout again, and we returned with no new data. But now from 55 to 54, within 4 seconds we got new data, so we returned with new data again. So you understand the drill. So if we get the new data within 6 seconds, we are returning with new data. If we are not getting new data within the timeout limits, we are saying that we don't have any new data. So this demo shows you exactly how long polling works. We have a timeout configured, and if new data arrives within the timeout, we return the new data, else we close the connection and the client will reinitiate a new connection. So let us now take a look at some of the major advantages of long polling. The first one is that we have reduced wasted requests. So in short polling, we had seen that we had a lot of wasted requests, but here we only return when there is new data or a timeout has occurred. So the total number of server calls that we make, that will be considerably less than that in short polling. So we have reduced a lot of wasted requests. So the second advantage is that long polling is more closer to real time than short polling, And that is because the data is pushed immediately to the client when it is updated. So we don't wait for the next interval, right? In short polling, if you remember, we used to wait for the next server call to get the latest data. So all the time in between the data getting updated and the next server call becomes your latency. So in long polling, we will have less latency compared to short polling because we immediately respond back whenever the data changes on the server. The third advantage is that it is widely compatible, just like short polling. Both of these techniques are compatible and supported by all major browsers, proxies, and firewalls. Long polling also happens to be very simple to implement. It is great for teams who do not want to get into the complexities of other techniques like WebSockets. Long polling also has a few major disadvantages, and let's take a look at them. The first disadvantage is server resource drain. And why is that? This is because instead of immediately closing down a request, we wait for certain duration. So if you imagine multiple clients connected to a server and each of these connections is kept open for a certain duration, this adds a lot of strain on the server and this is not ideal. The second disadvantage is connection overhead. Now, this was a problem that we already had in short polling and that exists here as well. Even though we are making reduced number of connections, we still end up making multiple connections, each of which have to be connected and disconnected after a certain duration, right? So this results in connection overhead, which is a disadvantage. The third disadvantage is really important, and that is the latency. So once you get the updated data, the server responds back with the updated data, but the client also has to reinitiate another connection. This small reconnection gap can miss ultra fast updates, something like stock values, which change very fast, right? So there is a considerable amount of latency because connections are closed and reopened. If you look at some other techniques like WebSockets, the connection is persistent, it remains open, and we have less latency. But in long polling, we see that the connections are closed and reopened, which result in some amount of latency, which is not suitable for certain applications. Alright, so we looked at the advantages and disadvantages of long polling. Let us now determine when it should be used. So if your requirement is such that you need a solution that is near real time, it is not 100% real time, but it is near real time and a few seconds of delay is okay or acceptable. So in such a situation, you can use long polling. It is a good alternative and it is really simple to implement. So it would be a good scenario to use when you don't require real time, but rather you require a near real time solution. The second scenario is when you need a simple architecture. So if you're working on something that needs to be quick and straightforward, and you don't want to get into the complexities of protocol upgrades or infrastructure upgrades, in such a scenario, you can use long polling because we have seen that long polling is really simple to implement. Also, it has great compatibilities, so you would not require any major upgrades to your existing infrastructure. And finally, long polling is used as a fallback strategy. So if WebSockets or server sent events fail for any reason, long polling is used as a backup. So even modern applications like Slack and Gmail will keep long polling as a backup and safety net whenever other techniques like WebSockets and server sent event fails. So if you're working on a product that needs to be robust and reliable, it would be appropriate to have something like long polling in the backup strategy whenever other techniques of fetching real-time data fail. Alright, so that's it for this video. We took a very comprehensive look at long polling and we understood several key items including the core idea, advantages, disadvantages. We implemented long polling in a coding demo and we finally took a look at where it should be used, right? So in the next videos, we will be taking a look at server sent events and WebSockets, which are used by all major companies to fetch real-time data.